now we're going to move on to chapter 4.4, ratio of volumes of similar solids. Previously, I went through this part on ratio of areas. So if the ratio of the corresponding sides is A to B, then their area is A squared is to B squared. You can think of it as, because we're comparing now the ratio of a 2D figure, so there are two dimensions, meaning there are two sides that you need to consider. So if, let's say, two squares, okay, this will be the simpler example, with sides A, and this one has side B. Okay, this is line A and this is line B. So the ratio of the area, this will be A squared, and this will be B squared. Because now we're talking about two-dimensional figure. So therefore, there is this square and this square. Okay, so this is plane figure, and for solids, it's the same thing. Because when we talk about the ratio of the area of their corresponding faces, because this again is two-dimensional, so don't forget this square. So for this chapter, we're going to talk about the ratio of their volumes. So when we talk about solid, right, when we talk about volumes, it is three-dimensional. So you have the length, breadth, and the height. Therefore, you should have this cube. So let's use the example of a cube. So take for example now, you have a cube of side A. Okay, length, breadth, and the height are all A. Okay, and then now you have your cube with length, height, breadth, all B. So this is a three-dimensional figure. When you talk about the volume, you have to go through these three: the length, the breadth, the height. So for this, length, breadth, height. Therefore, even if the corresponding size A is to B, when we talk about volume, there will be a cube. It is A cube is to B cube. Now to add on, there is one part here that you do need to take note. We are referring to similar solids. Okay, so what do I mean by this? So some of you may be wondering, like, this is convenient and this looks easy because I can just use A and B. So what if I have like other numbers that are not so nice? Like what if it's not a cube? What if it's a cuboid? So we have to keep in mind that we're talking about similar solids. So even if it's a cuboid, now let's say if it's a cuboid with like a length. Okay, so maybe we're talking about A, and let's call this 2A, right? So this is a cuboid, right? Okay, and we're comparing to another cuboid here that has to be similar to it. So what does it mean? It means that the ratio that corresponds should still be A is to B. We're talking about a similar ratio here. So I don't care if it's bigger, okay? I can have a B, and this has to be a 2B because we have to make sure that their corresponding sides ratio is still A is to B. So this is, look at the length here. This is 2A is to 2B, right? So at the end of the day, the ratio of the corresponding side is still A is to B. So let's compare the volume here. This is A, 2A is to B, 2B. So I have 2A cube is to 2B cube. And after simplification, it is still A cube is to B cube. So let's go through an example. So given the ratio of the area, so take note, we talk about area here, of the faces of two crystal cubes is 25 is to 49. Find the ratio of the corresponding sides of the cubes. So we know that for corresponding sides, if it's A to B, then when we talk about the area, then it's A squared is to B squared. And when we talk about volume, then it will be A cube is to B cube. So in this question, what we know is the ratio of area, which is 25 is to 49. So in part A, they want us to find the ratio of the corresponding sides, and that would be this one. So we just have to do a quick square root. So it will be 5:7. Okay, so that is part A. For part B, the ratio of the volumes. So volume requires the cube it, so it will be 5 cubed is to 7 cubed. So in your calculator, it will be 125 is to 343. Okay, and for part C is slightly different. We talk about the mass of the larger cube. So you want to find the mass of the smaller cube. When we talk about mass or when we talk about volume, we're generally referring to the whole thing as a three-dimensional figure. So we can continue to use the ratio of volume in this case. So we know that it is 125 is to 343. This is the basic ratio of volume of the ratio of the volume. So you want to find the mass, right? What you can think about now is this is the larger cube and this is the smaller cube. We have 343 unit. You can think about it this way. It's actually 686 gram. So you want to find what is this 125 unit. That would be 686 over 343 times 125. Although some of you can quickly see that this is just double, right? But I prefer this method because this is more generalized. You can use it for any numbers, even if it's not a nice multiples of it, of the ratio. So what you have is this is 2 times 125. So 125 units, okay, we take this ratio as units. Okay, so 125 units represents 250 gram. So this is the mass of your smaller cube.